This exponential growth or decay problem is regarding the population in a county. So the following function represents the population of Liberty County, where A is the population in thousand and then T is the time in years after 2011. So let's write the model again. So the model is A equals to 23.5 and then e to the kt. So e to the kt, we don't know the rate yet. Okay, let's use the givens to find k. So in this model, the initial population in 2011 is 23.5 thousand, k is the rate, and then t is the time. Okay, so what they are saying is don't plug in t equals to 2011. The initial year, so 2011, that is when t is equals to 0. And then at that time, the population is equals to 23.5. In fact, you don't even need to know the rate k. So once you plug in t equals to 0, and then e to the 0 power is equals to 1, and then the population is equals to 23.5 thousand. And then what else? In part A, in 2007, the population was that. Calculate the rate. Okay, so that means starting at part A. Okay, so they have 2007, right? So 2017 actually. So from 2011 to 2017, to 2011 to 17, you have to add 6 years to it, right? So that is t equals to 6. And then at that time, A is equals to 44.65. Okay, now the initial time is this, the initial population, this is in thousand, this is in thousand, so we will just work with these numbers. We don't have to multiply this by 1,000. So we don't have to carry too many digits in our calculation. Okay, so that is the population, so 44.65, and then equals to initial population, and then e to the don't know k, t is equals to 6, so that will be a 6k. And then we are solving for k, right? We are trying to find the rate, so calculate the rate. Calculate the rate. They asked me to find k. As always, I will divide the initial population on both sides, so 44.65 divided by 23.5, and then equals to e to the 6k. To bring the exponent down, I have to take ln on both sides, ln on the left, ln on the right to bring the exponent down. And then the next step is ln 44.65 divided by 23.5 equals to bring the 6k down, and then you have lne. lne is equals to 1, and then k is equals to ln 44.65 divided by 23.5, and then over 6. That is called the exact value. They asked me to round the k to 3 decimal places, right? Okay, so k, that is approximately equals to, you do that in your calculator. Oh, when you do this in your calculator, you type ln first, right? And then 44.65 divided by 23.5. Close the parenthesis, okay? Make sure you close the parenthesis. And then take the entire quantity divided by 6, okay? Take the entire quantity divided by 6. You only round one time. If you round the ln and then divided by 6, you round again, that accumulates round off error. Okay, so only round one time. And make sure you close the parenthesis before you divide it by 6. So this one, I have 0.107. So 107. And then this is greater than 0. So that means this is a growth. Exponential growth. Okay, the population in the number of people in this county is increasing. And then in part A, they also asked me to write the model. I said in the box, there is no box. Okay, I will just draw my own box. So A is equals to 23.5, and then e to the 0.107, and then times t. So this is my population model. So this is one exponential model that describes the population in this place. Okay, one function to describe the population in this place. And then in part B, they are asking, is the population increasing or decreasing? So the answer is pretty clear, right? So in part B, the population is increasing. Why? Because k is positive. The rate is positive. When the rate is positive, we say that as time increases the population increase exponentially. Okay, so exponentially. So that answers part B. And then in part C, in which year will the population of Liberty County be 70,000? So 70,000, you don't have to add 3 zeros at the end because every single one of this number is in thousand. Okay, so solve for that. Use a different color to do it. So in part C, we don't know t. So 70 equals to 23.5 e to the 0.107 t. We are solving for t. As always, I divide the initial population on both sides. So 70 divided by 23.5 and then e to the 0.107 t. And then you ln both sides. So ln the left, ln the right. So this is ln 70 divided by 23.5 equals to bring the exponent down 0.107 t and then multiply lne. lne is equals to 1. So you have t equals to ln 70 divided by 23.5 and then over 0.107. And then this one, just do this in your calculator when you do so, okay? When you do so, you type ln 70 divided by 23.5, make sure you close the parenthesis before you divide it by 107, okay? So make sure you close the parenthesis first, divided by 107, and then you just round that final answer. So since this is in year, right, we have to round this to the nearest integer, and I prefer to round up, okay? So this one, my answer, I just round this to 10. So this is the nearest integer. So nearest integer. And we prefer to round up. And then what is 10 represent? Well, that is the years. That is how we find the year. So the year is, the initial year is 2000 what? Initial population in 2011, okay? And then you add 10 to it. So that is year what? 2021. So that is year 2021. And then this is your answer for part C. Okay, so that is the end of this problem. If you like the way I explain math, give this video a thumbs up, subscribe to my channel for more contents like that. As always, we talk in the next video. Signing out.